So now what we want to talk about is acceleration. And acceleration is simply a change in velocity over some time interval. So it's really the rate of change of velocity. And that's important to remember, that it is the rate of change of velocity. Rate, whenever you see this word rate, it implies the factor of time involved because it takes time to change this velocity. So you could see if you change velocity, let's say you go from 0 to 60 miles an hour, and it takes you a long time to do that, you have a very slow or small acceleration. What happens if you go from 0 to 60 miles an hour in a very, very short time interval? Well, then you have great acceleration. That's like a racing car. So acceleration is this rate of change of velocity that we're talking about. Now, when we talk about change in velocity, we're talking about the final velocity minus some initial velocity over some time period. If you have a car that's going down a road, and very hard to draw these things with this pen, but let's say the car's going, and it's initially it's traveling at 5 miles per hour, and then 10 seconds later you see the same car over here is going at 20 miles per hour, and it took let's say 10 seconds to do that. So what would be your acceleration? Your acceleration is your change in velocity over change in time. And the change in velocity is what's your final? Your final is 20 in that direction, so it's plus 20 because you're going to the right, minus your initial, which is plus 5 because your initial is plus 5. So here's your final, V final. Here's your V initial. If you subtract the two, and it's going to take 10 seconds to do that, then what you're going to come up with is 15 divided by 10, or 1.5 meters per second squared. So the unit for acceleration, the SI unit for acceleration, is meters per second squared. And I want everyone to know that, because you should know that by now. The unit for velocity is meters per second. Unit for acceleration is meters per second squared. And I want you to know that average acceleration is the change in velocity over change in time. You need to understand that formula. You need to know what change in velocity means. Okay, it means your final minus your initial. So you got two different velocities, and if there's gonna be a change, you got to be able to subtract them and come up with some numbers. If you're going at a constant rate or a constant velocity, let's say you're moving at 5 miles per hour, and that's your velocity, and you don't change, it's just constant. So your acceleration, remember, change in v over change in t. Well, if there is no change in v, if that's 0 because it's staying constant, in other words, you're not increasing any speed or decreasing, then your acceleration is 0. And that's about all there really is to acceleration. Now, what I'd like to do is show you an acceleration plot and a velocity plot. So let's just do this. Let's clear this out. And do this. So here we go. First I want to show you, well, let me go back to velocity. Suppose this is position. Let's say this is position in meters, and this is time. Now you remember, with a position versus time graph, if you got straight lines, the slope of the straight line is velocity. Well, if you don't, let's say you have some kind of a curve like that, and you want to know what is the instantaneous velocity at this time. Let's say t equals 5 seconds. What's the instantaneous velocity right here? How fast is it? How fast is your object going right at this point? Well, the way you do it, since you don't have a straight line, you have a curve, you have to then take the tangent to this curve, remember? And the tangent line to the curve, the slope S-L-O-P, slope of the tangent line is going to equal the instantaneous velocity. That you need to remember. The instantaneous velocity can be found from the slope of a line drawn tangent to the position versus time curve at any point in time. So here you see at 5 seconds you've got a positive slope, and if you take that slope, you get the value of that slope, you'll find the instantaneous velocity. I don't think you're going to have to know how to calculate that, but you are going to have to know that the slope of the tangent line to a position versus time curve is going to give you the instantaneous velocity. This is true. Now for acceleration, as you might guess, acceleration, on the other hand, is going to be a velocity versus time plot. So if I have some curve over here and I want to know, say right there at this time of, let's say, 7 seconds, I want to know what is my acceleration right here at this point on this curve, this instantaneous acceleration. Well, again, I'm going to draw a tangent to it. There's my tangent line to this curve, and so the slope of the tangent line is going to be the instantaneous acceleration. I hope I'm spelling that correctly. Looks like it's time to plug in. So I'm going to just... Okay, so if I look at the slope of the tangent to a curve of velocity versus time, I'm going to get the instantaneous acceleration. If I look at the slope of a tangent to a curve of position versus time, I'm going to get velocity. So this is position versus time. This is velocity versus time. This position versus time is going to give you velocity. This velocity versus time is going to give you acceleration. Sorry about this. All right, we're going to talk more about this on the next video.